So we have this little site now that has a title, fortune cookie, and then underneath tells the user what their lucky number is, and the number is different every time they visit the page. So now, before going further, I want to take a break from adding new things and just take some time to talk about all the pieces that are coming together to make this possible. So I want to make it clear exactly what's going on. So let's start with just the action of visiting the page. I want to kind of pause and put that in slow motion and talk about everything that happens from the moment I visit this page in a step-by-step breakdown. So when I visit this page, the user is telling the browser, Chrome, that I want to visit this address. And by visit, what we really mean is I want to send a request. Please send a request, an HTTP GET request to this address. And then what Chrome is going to do is find this address and make that request, and then wait for the response to come back. So normally, if we visit a website like Facebook.com, this word, Facebook.com, translates to an IP address somewhere, the IP address of some computer somewhere in the world, like Arizona or Iceland or something, where a server is hosting Facebook's site. So what my browser does is it says, behind the scenes, it's going to figure out what that IP address is, and then it's going to send the request to that IP address. And then, obviously, we receive back a ton of HTML outlining exactly what this, and CSS and JavaScript, telling our browser exactly what this page should look like, and then the browser displays it. Now, in our case, we don't have our fortune cookie website out on the internet, hosted on a server somewhere, because we're still working on it. But what we can do is set up a local server to simulate, like a fake server, so that we can work on it and see what a hypothetical user would see, so that we can get feedback as we're working on it. And so that's what one of the big services that the App Engine Launcher is doing for us right now is setting up a local server that is listening for requests to this fortune cookie, and when it receives those requests, sending back whatever we tell it to send, and that's our job by writing this code. So the server is essentially just sitting there somewhere on my computer here, and it's waiting and it's listening. And if it ever receives any requests, it's going to run our code and send some content back to whoever made the request. So as soon as the user on Chrome here hits enter, a request is going to get sent to this place, localhost at this port. So localhost is just a specific place where this server is running, and that's where the request gets sent, and that's where the server is listening for requests. And the port isn't something you really have to worry about. The point of the ports is just so that theoretically you could be serving multiple things on the same machine at the same time, and they wouldn't be interfering with each other. So whenever I hit enter here, our server is going to get that request. And so one thing that is going to be really helpful is I'm going to open up this logs view so that we can see this process happening. And let's see, I'm going to clear it and do it again. So notice that each time I visit the site, we get a new item here. So basically each of these rows is an event that occurred that our server is taking note of. So most of this, we don't have to dive into the details, but so we have a timestamp here saying when it happened, and here we see basically this says a GET request was made. So remember, there's a couple categories of HTTP requests. There's GET, POST, DELETE, and some other stuff. So a GET request was made, and the 200 code was returned, and 200 means okay, everything went okay. So this is just to show that each time we quote unquote visit a site, what's really happening is our browser is sending a GET request to a server somewhere, like this one. And this server is taking note and then responding with some stuff. In our particular case, what the server is responding with is this stuff. So our code here is our opportunity to decide what should be in the response. So now this word response should make a little more sense. Exactly what we're doing with this line is we are writing the HTTP response that is going to be sent back to a browser. So we've talked a lot about the code we wrote. We haven't talked a lot about sort of this outer infrastructure that's built around it. So now is a good chance to do that. So if we head back here to the logs again, let's look a little more in depth at this. One thing I want to point out is this right here, get/HTTP 1.1. So this slash is actually very important, and what it signifies is that the request was made specifically to the slash route. And what this slash route really means is the home page. So it's slash in the sense of, when you go to, if we go back to Facebook for a minute, notice how, maybe I could go here, right? And if I go to facebook.com/login, it's a whole new, I get a new response with new content specifically related to logging in. So what the slash over there really means, it's referring to this little slash here. So it's kind of confusing because it's kind of a lack of anything, but slash means yourwebsite.com/nothing, because we want the root homepage of your website. And that slash in the HTTP request that we see here corresponds directly to this one here. So when the request comes in to localhost at this port /nothing, the server tells our Python program, hey, a request just came in to the /nothing route. Please give me back a response so I can pass it along to the browser. Our program's job now is to give the server what it needs so it can pass the response along. So I'm going to trace the flow of decision making, basically, without really worrying about the exact Python syntax for how that happens. Don't worry about syntax right now, just semantics. Just focus on the flow. I'll go back and talk about semantics in a minute. Syntax in a minute, but for now, just want to focus on, at a very high level, it's easy to see what's happening. So the server's asking, originally the browser's asking for the /route. So now the server's asking our program for a response to the request from the /route. So this here is our program saying, when a request comes into the /route, I want that to be handled by the main handler. So because it's the /route, we're going to go to the main handler, and then because it's the HTTP GET method, we're going to run the GET method within this main handler object. So this method gets executed, and that's why our code in here produces the response that the user ultimately sees. So, and then the last line, as we talked about earlier, is literally writing the response that's going to be sent, and this is the content that goes into that response. So hopefully that flow within our program makes sense. And so just to review the entire process one more final time, here I am, the user in the browser. I hit enter. As soon as I hit enter, Chrome makes a request to the server, which is located here, which we have running. We have it running there, and we're telling it that when you receive requests, you should serve up the content provided by the fortune cookie program. Now the server runs the fortune cookie program. It goes to our main.py file and runs that file and asks it for the response to the /route. And our response goes through this flow and results in this stuff being sent back to the browser. So a second later, the browser receives that, and it knows what to do with it because it's a bunch of HTML, and so it displays that HTML on the page that the user sees. I think it'll be helpful to see what happens once we start adding additional routes. That's going to make it more clear how this this line of code, which looks kind of weird in a lot of ways, maps onto the process. So, for example, let's say I were to visit now the home page. We'll pretend this says fortunecookie.com/login, for example. If I visit this, we don't see a normal content. We get a 404 message. This resource could not be found. And so why is that the case? That's the case because we haven't registered a handler for that route. The only route right now that we are capable of serving content to is the home page. If we wanted to support another route like login, we could very easily do so. We just have to add another item to this list. So notice that we're actually inside of a Python list here. We have the opening brace, or the opening bracket here, and the closing here. So each item in this list represents another route that we want to be able to handle. So if I want to add another thing here, I can just add a comma after this first item and add a second item. So let's say we want to handle something at the /login route. Forgot the slash. If we wanted to do that, we just have to add this. So let's just say for now that this route is also going to be handled by the main handler. And if we do this, we should now see, hopefully, that if I visit login again, I should see the same content. Yeah, great. So if I'm trying to go here, if the user's trying to go to our site /login, now the Python program says, oh, I know how to handle that. I'm going to use this handler here. Now, let's just, for the sake of fleshing this out a little more, let's say, just like Facebook gave us a different page for logging in versus visiting their home page, let's do the same thing ourselves. So let's say, instead of this being handled by the main handler, let's make a new handler called, say, the login handler. Seems like a good name for that. So now that we have stated that we're going to use this login handler to handle this route, we need to actually define this, or else our program is not going to work. In fact, let's see what happens if we do this. It's going to break somehow. I'm not exactly sure what to expect. So in this case, we get a different error. It's not a 404 because our website can handle this route, instead what we got is something, our Python program crashed, essentially. So instead of a 404 error, we get a 500 error, which signifies that the application that's running on the back end on the server that you're trying to talk to is somehow broken. And of course it's broken because we're trying to use a class that we haven't defined yet. So let's go back. Oh, also, before we fix this, note that we got some nice information here on the console. So note that if you're working on something and you get a cryptic message that's not helpful, you might be able to find useful information to help you debug it on the console. And yeah, exactly. So we can see here the problem, login handler is not defined. And we can see the line number that is causing the issue, which is line 32. So now let's go ahead and define this. So I'm going to make a class called login handler, which should inherit from this other class coming from the web app 2 library. And I'm going to talk more about both this class and the inheritance process and the library in a minute. But for now, let's just kind of go through the motions. So I have this class, and within that, I'm going to make a get method, a method whose name is get. And within that, I'm just going to put something really simple. I'm going to write, thanks for trying to log in. Doesn't really make much sense, but it's something. Okay. So now our site, our application, is capable of handling requests to either of these routes, and we're going to get a different response depending on which route was visited. So hopefully that makes sense. And now, as promised, I want to go back again and take another pass at this same stuff, but looking even more detail at the low-level mechanics of the Python syntax that we're using to accomplish this process. So let's start with this line here. So like I said, this is just a list, and in fact, maybe we could even illustrate that by pulling it out here. So I'm going to just make a variable called routes. Routes is a list that has these two routes. These are the two routes that we are capable of handling. And then app is an instance of this thing, which takes routes. So all I've done is pulled the routes themselves out into a variable, and then I'm passing them in by referring to that variable. So we should see no change here. Everything should work normally, and it does. So now let's talk a little bit more about what's going on here. So all we're doing here is we're making a new instance of this object, a WSGI application object. And in order to make one of those things, we have to give it some routes that it's capable of handling. And this thing is qualified by web app 2 dot in the same way that something like this, when we tried to make a random number up here, was qualified by random dot to just say that this method is defined in this library here, which we imported. So in the same way, this object, this class, is defined in this library, webapp2, which we are importing and using. And so what we're doing here is we're calling the constructor of this object. So recall that anytime you define a class in Python, and then you want to make an instance of that class, you call its constructor. So like in Unit 1, we had some stuff like cats and tigers. We had class cat, which had some methods, something like this, right? And then down below, we would say Hobbs equals a new cat. So here, we are calling the constructor of the cat. And that will give us one new cat, and then we're storing that in a variable. So in the same sense, we are creating an instance of this application thing by calling its constructor, and then we are calling that instance, we're giving it a name, a local variable name of app. And in the case of this object, the constructor needs some additional information, of course, right, which is these routes, the routes that we're going to handle. This here, debug equals true, just helps. I'm not sure even exactly what this does. I think maybe it sort of is a configuration on how much stuff gets logged here, and I think it does various things that make it easier to debug when you're working on it. So for now, it's probably good that we have that, but don't let the presence of that distract from the main important stuff. So this is really all that matters here. And I assume even though if I get rid of that debug equals true flag, everything's still going to work perfectly fine. And yes, it does. So that's what's happening here. Now let's go back and look more deeply at our handler classes. So the first thing to notice is that our classes, in these parentheses here, we say webapp2. In both of them, we say webapp2.requestLengthHandler. So recall that this in Python is the syntax for specifying inheritance. So when we put this in parentheses next to our new class, what we are specifying is that we want this class to inherit from the parent class of this thing. So this is another, just like WSGI application, there's another class that's defined in this library called request handler, and that obviously is a class that's capable of responding to HTTP requests and giving back nice responses. So recall that inheritance allows us to essentially make a new class that acts very similar to this one, and we get all of its functionality for free, but then we can extend it or customize it however we want without having to redefine all the functionality that was already defined in here. And it is important that we do inherit from this class because the functionality that we're inheriting and the things that it's doing behind the scenes without us having to worry about it is actually pretty large. There's a lot that goes into making a valid HTTP message that is able to be sent across the internet such that the browser, when it receives it, knows what to do with it. So we only have to worry here about the content that's going in there, but there's all kinds of important metadata and stuff that should additionally be sent. So for example, we are responding with this 200 code, or in the cases where something went wrong, it was a 404 error or a 500 error. So that's just one example of like something that we didn't have to manually do ourselves because this class knows which response code to attach to the message, depending on whether it worked out okay or whether there was an error, and if there was an error, which kind of error, etc. Notice also that we get this response just as a cat might have a property like color or sharpness of claws or something like that. Our handler has a property called response, which represents the response that it is going to send out, and we get to just use that and call its write method and all kinds of stuff without ever having to define it ourselves, by virtue of the fact that we are inheriting from this base request handler class. And so to illustrate the importance of this, another little thing I want to try is let's put something here that isn't a request handler. So what if I actually tried to say that requests coming into the /login route will be handled by the cat class. So let's test this out, and I'm gonna move the cat up here so that it's defined before we try to use it. And let's see what happens. I imagine something is going to go wrong, but I'm not sure exactly what. So we got a 500 error, and if we look down at our logs, we can see it's complaining about, it says this constructor takes no arguments, so presumably referring to the cat class that we made, and we can see that the line of code that threw the error is webapp2.py on line 1101. So this is nice because it allows us to see that webapp2.py is a real piece of code somewhere. And when we tried to use this cat class as a request handler, that's causing all kinds of problems for our library's attempt to do its job, because it's expecting various abilities of that whatever class is supposedly going to be able to handle a request. And to be honest, they didn't do a great job here. WebApp2 didn't do a great job of handling the error in such a way that makes it obvious to us, the silly developers who made this mistake, exactly what the mistake was. It would have been maybe nicer if they had said something like, any class that's used to handle a route must inherit from the request handler class, or something like that. They don't explicitly tell us that, but it appears that anytime we want to put a handler here, it should inherit from this class. Otherwise, we're going to get problems. So another experiment I want to try is, let's go back to this and just remove the inheritance. I imagine we're going to get the same error, but it might be worth just trying. Yep, we got the same error. So yeah, definitely seems that anything here must be a class that is a request handler or a subclass of a request handler. The last thing I want to talk about, and I'm going to get rid of this cat now, we don't need that. The last thing I want to talk about is this get method. So each of these classes, we define a method called get. And the reason it's called get corresponds directly to this word get. So basically, remember that there are a bunch of different categories of HTTP requests. The most common is get. The second most common is post, which is used for trying to update data in a database somewhere. Then there are less common methods like delete and others, but the main two to care about are get and post. And so having this method get here is our way of saying if a request came into this handler and it was a HTTP GET request, then here's what you should do. So to illustrate that, what if, let's just change the name of this to something else, doesn't matter what. The point being, I no longer am providing my own implementation of this GET method, because I don't have one here. I have a method called cookies, but I don't have a method called GET. So let's see what happens if we try to send a request to the login handler now. So notice we get a different error here, which has a name that makes perfect sense. Method not allowed, and then the subtext says the method GET is not allowed for this resource. So because our login handler doesn't define a method called GET, that means that our app hasn't specified how a GET request to this route should be handled. So if we're going to make a handler that is capable of receiving GET requests, then our subclass needs to define a method called GET. And all of this is just the particular design that is dictated by the Web App 2 library. So the Web App 2 library is a library kind of just like any other one, and it's a library that allows us to set up a web app. And the way they happen to define it is they make this request handler class that we are supposed to inherit from with our own subclasses. And within those subclasses, we need to define a GET method. And similarly, if we want to handle post requests, which we will see in the next few weeks, then we're going to need a new method called post to handle those instead. But so the particulars of how this stuff happens in our Python program here is not, the point I want to make is that the details of the syntax here and the way and the design of these classes and what methods they have and the names of those methods like GET are all specific in this case to this Web App 2 Python library. They're not, it's not universally always going to be the case if you were to use some other framework or library to do this. But the more general pattern you can take away to any other context in any other language with any other framework, namely the pattern of a browser sends an HTTP request to a server. The server's job is then to run your application, which you've written, and it may look like this, or it may be in another language, or it may use a different library. But in any case, that application that you wrote is responsible for giving a response, an HTTP response, that the server will then send back to the browser. So anytime you're making a website or a web application, what you're really doing is writing code that responds to requests at different routes, different types of requests, and for each of those produces a response that's going to make sense in the world of HTTP. And there are different particulars in terms of how that's done. In our case, for this unit, we're going to be using Web App 2, and it looks something like this. So hopefully all that makes sense. What I want to do next is get back to the work we were doing, and let's finish implementing our fortune cookie site.